Problem 5, we need to calculate the number of tests we need to do by the second method. While the second method says that we divide 100 people into 10 groups, and with 10 people in each group, we mix their blood and test that mixture. So we have the notation here, MP, to denote that the mixture's test result is being positive, and its counterpart Mn denotes that the mixture test result being negative. And as we know that both MP and Mn are counterpart of each other, so we have P MP plus P Mn equals to 1. And because if the mixture test result is negative, then each person's blood in this mixture must be negative. So we have the probability of Nm equals to each person's blood being negative, which is 1 minus 0.1 power of 10, 0.9 power of 10. And so we have P MP equals to 1 minus 0.9 power of 10. So here is for the mixture test results probability. And we need to calculate the number of tests for the 10 people in a group. And this is an expectation value, which equals to its two parts of probability. The first one is the mixture test being positive. Then we need to take an extra 10 tests to make sure that each person's test results are positive or negative. So here we need 11 tests. But if the mixture test result is negative, which means that each one's blood in this mixture must be negative. So we just need to make the test for one time. So here is 1. And this is for a group of 10 people. And here we have 100 people. So the total expectation of number of tests we need is 10 times the expectation of 10 people's time. So we should plug in the formula that we should plug in the number we derived above, which is 10 times the probability of MP, which is 1 minus 0.9 power of 10. 1 minus 0.9 power of 10 times the times, which equals to 11 plus 0.9 power of 10 times 1. And after calculation, we get the final result equal to 75 plus 13. So we need around 75 times to test if we do this test by the second result, which is greatly lower than the 100 test if we use method 1. And here the main part here of this problem is we should notice that the mixtures tests, both being positive and negative, they are mutually counterpart of each other, and their summation equals to 1. And also that we need to know that if the mixture is negative, then it is certain that each person's blood in this mixture must be negative. So based on these two assumptions that we have derived that the probability of MP and Mn here. And the other thing is not in this problem that we need to know how to calculate the expectation value. the expectation value formula, as I have right here, is x times p, the probability of being x, and the summation as we have known here. And that is for the problem 5.